Welcome to my YouTube channel. In this video, we are going to learn how to derive various equations governing blocks sliding down an inclined plane for different situations. So the first one we are going to be looking at is a block sliding down an inclined plane with no friction. So this is a diagram that depicts such a scenario. So we see the block sliding down this direction. We have the forces acting on this system. The first force is the weight, mg. The next force is this particular one, which is mg cos theta. Right? We can resolve this one along this particular one, which gives mg cos theta. The angle here is exactly the angle here, which you can always show that this angle is equal to this angle. Then this particular one here is mg sin theta. You can see opposite all over hypotenuse. This is hypotenuse, while this one is adjacent all over hypotenuse, right? So with this, we have that this particular force can be extended to this part. So that's why this one is mg sin theta. So if we resolve the forces along the x-axis and along the y-axis, we see the forces that are responsible for the slide to move down along the x-axis. So the first force is what we are going to present here, which is mg sin theta equal to ma. So the only force acting on this system along this plane is mg sin theta. So that mg sin theta must be equal to mass times the acceleration, right? And if you compare these two, you notice that m can take care of this m, so leaving a equal to g sin theta, and that leads to a equal to g sin theta. So you might be asked to find the acceleration of this kind of system. All you just need is the angle, then multiply sin theta times g will give you the acceleration, right? So this one means that the mass is independent on the acceleration does not depend on the mass of the object, right? So if we also resolve along the y, we take care to be the y, you notice that this your r is pointing this way, and this one is also pointing this way. So that means r minus g cos theta must be equal to 0, since the block is not moving in this direction. So if you now resolve it, you will realize that r will now be equal to mg cos theta, and that gives us r equal to mg cos theta. Now if you compare this equation with this equation, you notice that we can divide this one, we can divide this equation by sending this one here and sending this one here, and that gives us ma all over r, that's ma all over r, mg sin theta all over mg cos theta, and that gives us tan theta. Mg cancels mg, leaving this, and finally we have tan theta equal to ma all over r, where our r here is the reaction. So depending on what you are asked to find, once you know all the parts that are given, you can always find the unknown with this equation and this equation, right? So we move on to the next scenario, where we have a block sliding down an inclined plane with friction. The previous slide is with no friction, but in this slide is with friction. So let's see the diagram describing such scenario. So we have a friction moving in this direction, opposing this motion, while this one is moving downward. So as usual, let's resolve this particular force along the x-axis, and that will be my mg sin theta minus this force must be equal to mass times acceleration, and that gives us mg sin theta minus f equal to ma, right? So but we notice that our f is always mu times r, which is the coefficient of friction times the reaction, and that gives us we can also say that our r along the y-axis is r equal to mg, which is known. Then by the time we find the f, we replace f with mu r, we'll have mg sin theta minus mu r equal to ma. That's from here we have this f is generally known to be mu r. Then our r now has been found to be mg cos theta, so we can substitute mg cos theta here, and that gives us mg sin theta minus mu mg cos theta equal to ma. So m and m can take care of each other. We can take care of m, and that leads to mg, right, from these points. and from there we move on to g sin theta minus mu cos theta equal to what? A. Right, so our acceleration for this system is given by this. So if you notice, if there is no friction, that means this one will be set to 0, and if this one is set to 0, you will realize that our acceleration will now become g sin theta, which will fall back to the previous slide equation, right? So that's it. So we move on to the next possible scenario. So this time I will look at block static on an inclined plane with friction. That means this block is not moving, or it can also be moving at a constant speed. Any one of these two scenarios can be taken care of by what we are going to be seeing here. So this body is static, right? So in such a scenario, we say our mass, right, mg sin theta minus the frictional force must be equal to 0, and that gives us mg sin theta minus mu r equal to 0. So as usual, our r along the y-axis is y, r equal to mg cos theta. Okay, so remember that our f is mu r, and this mu r can come to this part, and we have this expression. Then our r, where our r equal to mg cos theta. So if we substitute the value of r into this part, we will have mg sin theta, which is this part, equal to mu mg cos theta. So we can make mu the surrogate formula, and that gives us okay, we just take our mg out, and we have sin theta equal to cos theta, and we'll make our mu the surrogate formula, so mu equal to tan theta. So for this scenario where the block is static or it's moving at a constant speed, the coefficients of friction, right, can be equal to this particular one. I hope that's okay. So when it is static, this one will be the coefficient of static friction. When it is sliding, this one will be coefficient of what? Sliding friction. Okay, so let's move on to the next scenario where we have a block sliding on an inclined plane with friction and external force. So this is the diagram describing it. So there's a force pulling upward. The weights, this mg is pulling opposite, while friction is also in this direction. So as usual, what we now have is, if it's moving in this direction, F minus mg sin theta minus frictional force must be equal to ma. So we have F minus mu r minus mg sin theta equal to ma. So, but we already know our r equal to what? Mg cos theta. We can decide to substitute that one, or depending on where we want to look at, maybe make this one F the surrogate formula, depending on what you are looking for. So our r equal to mg cos theta, then F equal to mu mg cos theta minus mg sin theta equal to ma. So from here we can make our a the surrogate formula, and that gives us a f minus this divided by n, which is equal to this. So this is the acceleration for this system, where f equal to this and this and this. So you notice that if our a here is 0, that means it is static. We can find the force needed to make this body move. In that case, we make here 0, and if here is 0, this part comes here, we now have f will be equal to this one plus this, and that is found here. F equal to mu g, this, and at the end we make f the surrogate formula, which is this. So this formula is useful when the block is not moving, but you are asked to find the force needed to set that block in motion, and so this is the formula you need to use, right? Okay, so let's see the next scenario. We have block sliding on an inclined plane with friction and external force in different direction. Okay, so this is the diagram. So from this diagram we can see that our f is in this direction, which makes an angle of alpha, and this particular one mg sin theta. So if we are to resolve along the x, right, we can resolve this one in this direction, and this one will now be, if we resolve this one in this direction, it will be what? F cos alpha, this one will be f cos alpha, because this is adjacent all over hypotenuse. F cos alpha. So that F cos alpha minus this will be equal to what? The MA. So let's see it. F cos alpha minus mg sin theta minus mu r equal to MA. If we resolve along this vertical, you discover that there are three forces in this direction. So R is one of them, mg cos theta is one of them. Then the force, if we resolve the vertical here, so you see that this one is pointing upward, because you can move from this direction up. Instead of moving from here to here, we can move from this point up. So this force here, the vertical component, is F sine alpha. That F sine alpha is in line with R, so we can say F sine alpha plus R minus mg cos theta equal to 0, because this static block, this block is not moving in this direction. So, and that gives us R, which is this R, plus F sine alpha must be equal to this. You know, we said R plus this minus mg cos theta equal to 0. So that minus brings this one here, and we have this one. So if we resolve this one properly in terms of F and R, and send any other thing that does not contain F and R to this other side, we have, for this first equation, we have F cos alpha minus mu R, which is this, equal to mg sin theta plus MA. If we rearrange this one, it becomes F sine alpha plus R equal to mg cos alpha. So these are the two equations governing this particular system. So a problem might be given where you are asked to find the value of F and the value of R when n is given, maybe the angle is given and this alpha is given. You might be asked to find the force needed to pull this one up, the reaction, or depends on what you are. Even you might be asked to calculate A if F and R is also given, right? So that's all. So once you know how to derive this formula, you'll be able to solve any problem that comes your way. I hope this helps. Please like, share, and subscribe to this YouTube channel. Thank you for watching.